Let's take a look at the pancreas. The length of a typical pancreas is about 10 to 15 centimeter long. So as you can see that the pancreas is a normal pancreas is quite long. It is about 10 to 15, which means it's about as long as the trachea. The trachea that's situated in the neck. Now, it's divided into three parts: the head, the neck, the body, the tail, and lastly the uncinate process. Another thing we can see is the fact that the entire structure is retroperitoneal. That means the anterior portion of the pancreas is covered by the peritoneum. It's shaped like a flattened tongue and is lobulated and yellowish in color. Like a normal pancreas is sort of pinkish, sort of yellowish in color. The superior relation of the head of the pancreas include the first part of the duodenum, then we have the pylorus of the stomach, and the duodenal papillae of the second part. Okay, so that right there is the head of the pancreas. And let us look at it from the more posterior aspect because we're studying the anterior relation. So that's going to be the superior aspect of the head of the pancreas. And most adjacent to it, we can find that there is the first part of the duodenum. And then we have the pylorus right here. So the anterior relation, the superior relation is the pylorus. Then we have the first part of the duodenum, and then we have the second horizontal part right here. So three major superior relations. Inferiorly, we can notice the third part of the duodenum, and then we have the uncinate process, which is in continuity with the head of the pancreas. So as you can say inferiorly, this is the third portion of the duodenum, and then this small region right here is known as the uncinate process. Anteriorly, we can find the covering of the peritoneum, and then we have the mesocolon of the transverse colon. So right there, we have the transverse colon, and behind the transverse colon, attaching it to the posterior abdominal wall, we have the mesocolon. So that's the anterior relation, and then we also have the peritoneum that's covered. So the pancreas, the entire pancreas is retroperitoneal. So we can say that anteriorly there is a small covering of the peritoneum that we can see here, the peritoneum. Posteriorly, we can observe the common bile duct. Then we have the common bile duct which joins to the pancreatic duct. Then we have the inferior vena cava, and lastly, the right cruciate diaphragm. So the posterior relation, right here, we can see that there is the inferior vena cava. So that's the inferior vena cava, and then we have the ducts that arise from the gallbladder. So the first duct we can see here is known as the bile duct, and then the bile duct goes and it gives off the pancreatic duct. Now let us see the pancreatic duct here in more detail. So if I'm gonna just let you know that it just goes and runs along the length of the pancreas posteriorly. So yeah, that's the pancreatic duct. Now let us look at the neck of the pancreas. The anterior relation of the neck of the pancreas include the pancreaticoduodenal artery, then we have the gastroduodenal artery, and lastly we have the covering of the peritoneum. The anterior relations are quite visible here. As you can see, we have the gastroduodenal artery right here, and then we have the pancreaticoduodenal artery, which are in close relation with the neck. So they're very laterally aligned here in this image. However, there is a high possibility that in the real anatomical structure of a human being, you can find that this entire structure is a bit inclined towards the neck. Posteriorly, behind the neck of the pancreas, we can see that there's a junction of the portal vein, the splenic vein, and lastly the superior mesenteric vein. If you observe it in the atlas over here, you can see that it's quite visible. So that's the pancreas right there. And if you sort of rotate the structure posteriorly, so I'm going to rotate the structure posteriorly here, you can see that. Just a second. After Rotating the structure posteriorly, you can see that just behind the neck of the pancreas, there is the conjunction of the portal vein. This is the portal vein. Then we have the splenic artery that goes along this side, and then we have the superior mesenteric. Okay, so portal vein, the splenic vein, and the superior mesenteric vein. Keep that in mind. The body of the pancreas is the largest part of the pancreas and is in continuity with the neck. So anteriorly it is covered by the peritoneum, but posteriorly it is not covered by the peritoneum. Then anteriorly we can also find the transverse mesocolon. Next, we can also find the lesser sac of the stomach, and lastly, the small intestinal tract. And in the small intestinal tract, the closest part to the anterior part of the pancreas include the fourth part of the duodenum, the duodenojejunal flexure, and lastly, the coils of the jejunum. Now, let us look at the superior border of the body of the pancreas. The superior border of the body of the pancreas is in close relation with the celiac artery, then we have the common hepatic artery, and lastly, the splenic artery. Let us look at all of these structures on the atlas. So that is the superior border of the pancreas, the body of the pancreas, this one right here. And you can see that there is the celiac trunk, and coming off the celiac trunk, we have the left hepatic artery, the common hepatic artery, and the tortuous splenic artery that forms the upper border of this of the superior upper border relation. All right, now let us observe the anterior relation. The anterior relation includes this lesser omentum right here, and then we have the fourth part, the part of the duodenum. So that's the duodenum right there. We're not going to consider the other parts. But as you can see and observe here, we have the fourth part of the duodenum, which is in close proximity and lies anteriorly to the pancreas. And then we have the transverse mesocolon, not the colon, that's a colon. And behind the colon, we have the mesocolon. So remember that the transverse mesocolon, that goes behind, that lies anterior, the peritoneum, of course. And then we have the duodenojejunal flexure. So this is the duodenojejunal flexure here, and the anterior part of the jejunum, which is in close contact and lies anterior to the pancreas. Let us look at the posterior relation of the body of the pancreas, which includes the suprarenal gland of the left kidney. Then we have the upper pole of the left kidney, and lastly we have the splenic artery, the tortuous splenic vein, and actually not the artery, the vein. And then let us look at the other structure. And lastly, we have the renal vein too. Then there's the other structure, or the inferior border of the pancreas. The inferior border of the pancreas is in close relation with the confluence or the convergence or the crossroad of or the meeting point of the splenic, the superior mesenteric, and the inferior mesenteric veins. So that right there is are the posterior relations of the kidney. So that being the upper pole of the left kidney, of the pancreas, sorry. So that being the upper pole of the left kidney. Then we have the suprarenal gland, and then we have the splenic artery. So that's the splenic, sorry, not the splenic artery, the splenic vein. That is the splenic vein, and then we have the renal vein, and lastly, near the lower border, we have the mesenteric, most of the mesenteric relations. So starting with the superior mesenteric vein right there, so that's the superior mesenteric vein. There's the inferior mesenteric vein right here, which is not really present, and it converges with the superior mesenteric and the splenic, and then we can also find some mesenteric vessels right here. So three of the things come in close contact and converge behind and form the posterior relation, but most mainly the inferior border of the relation of the inferior border of the pancreas. Then we can also find that one of the major posterior relation is also the perirenal fascia. So there is a thin sheet that covers the renal gland, or the kidney, that forms the perirenal fascia. Then we have the tail of the pancreas. The tail of the pancreas is about 1.5 to 3 centimeter and is the most distal part of the pancreas. It is long and narrow, and it is in relation with the splenic artery, the splenic vein, and lastly, it also is in close relation with the splenic hilum. Then we have the uncinate process. The uncinate process is said to be separated from the entire body, the head and the neck of the pancreas, embryologically. But as the human being grows, the uncinate process it fuses with the inferior portion of the head. Now we can see that the uncinate process is in close relation to the abdominal aorta that is present posteriorly and also to the fourth part of the duodenum. Okay, so that's the tail of the pancreas right there, which is will in close relation, as you can see, to the hilum of the spleen. Then we have, okay, so I'm going to rotate the structure and look at it at the posterior aspect. So in the posterior aspect, we can observe that we can see that there is the splenic artery and the splenic vein that is also in close relation with the splenic with the tail of the pancreas. Then another thing to consider is that anteriorly near the uncinate process, we can find the fourth part of the duodenum, this ascending part. This is the uncinate process, and then the fourth part of the duodenum, also known as the ascending duodenum, is in close contact with it. Then also we have the abdominal aorta. You can see how closely the abdominal aorta is posteriorly associated with the uncinate process. The supply to the pancreas is mostly carried out by the branch of the abdominal aorta known as the celiac trunk. Coming off from the celiac trunk, we can notice that there is the gastroduodenal artery. Gastroduodenal artery divides into two major arteries that supply the pancreas, namely the anterior pancreaticoduodenal, and then we have the posterior pancreaticoduodenal. We have another major branch that serves as a primary supply of the pancreas, namely the superior mesenteric. And coming off of the superior mesenteric, we can find the inferior pancreatic or duodenal. The body and the tail of the pancreas have different supply, namely the splenic artery, and then we have the dorsal artery. There are also certain arcades or anastomoses of arteries that form an arc-like structures around the ventral side of the pancreas and all around the pancreas to be more precise. And one such example of such arcade is known as the Kirk's arcade. Now let us look at all of the arteries that we spoke about earlier. So that is the celiac trunk right there, approximately at the level of, I think that's the T12 thoracic vertebrae. So approximately at the level of the superior part of the L1, we have the coming off of the of the celiac trunk. The celiac trunk goes and divides itself into, branches out into the splenic artery, and then we have the the hepatic artery. Yeah, that's the hepatic artery right there. Coming, okay. So the celiac trunk goes off and divides into the hepatic artery, and then we have the splenic artery, the tortuous splenic artery. So the hepatic artery forms the anterior. So this is a gastroduodenal artery. The first branch is the gastroduodenal, and coming off of the gastroduodenal is the anterior pancreaticoduodenal artery, and then we have the posterior pancreaticoduodenal artery, as we can observe here. And so that's how there is a division of this structure. Then we also have some different other structures known as the prepancreatic artery, and then we have the dorsal pancreatic artery. Dorsal pancreatic artery is this one, this one right here, and or the inferior pancreatic artery, it comes off of the mesenteric artery right there. So we have also a branch that comes off of the splenic, sorry, not the mesenteric, the splenic. So one branch coming off of the splenic artery, giving off the inferior pancreatic artery, and the one that goes on the other side. And hence you can see here that there is an arc-like formation or an arcuate formation. Then Yeah, so that's all we can see right here. That's the anterior, then the posterior, and then we have the celiac coming giving off the gastroduodenal. Coming off of the gastroduodenal, we have the anterior and the posterior, then the splenic giving rise to the inferior and the formation of the arcuate structures. The venous supply or the venous drainage of the pancreas. The venous drainage is mostly done by two major veins, namely the superior mesenteric and the splenic vein. The superior mesenteric and the splenic vein converge onto a common point behind the pancreas and join into the portal vein, which goes into the liver. The superior mesenteric has branches of gastroomental, pancreaticoduodenal arteries that go and supply and drain into it. And then we have the splenic vein, which has which have pancreatic veins that go and drain into the splenic veins. So if we're going to go upwards, we can see that there is this entire group drains into the superior mesenteric artery, which drains into the portal vein, which goes into the liver. And then this group of pancreatic veins go and drain into the splenic vein. And the splenic vein also goes into the portal vein, which goes into the liver. Now let us observe the entire this on the map right here. So that's the superior mesenteric, and that right there is the splenic. And coming off of the splenic, if I'm gonna just like take the vertebral column out of the way, we can see that posteriorly there is the splenic vein that sort of extends all the way from the body to the tail. And then we can see that there are these short branches right here, which are known as the pancreatic veins. Then the pancreatic veins also arise from the superior mesenteric artery. The superior mesenteric artery is also responsible for the drainage that is received from the head of the pancreas, from the pancreaticoduodenal veins. So these are the pancreaticoduodenal veins. Then we have the omental vein coming and draining into the superior mesenteric. So as you can observe right there, so this vein right here, we can see that this draining into the superior mesenteric. This vein right here is known as the gastroomental vein. This vein. Then we have the anterior and the posterior pancreaticoduodenal vein right there too. So this one, anterior and the superior. And then this one is the splenic vein that is also responsible for the drainage into the hepatic portal system. Let us take a look at the pancreatic microstructure. The pancreatic microstructure has an endocrine component and an exocrine component. But most of the component is like most of the pancreatic microstructure is exocrinic in nature. At about 98% of the entire microstructure is only composed of the exocrine component. Now, if you look at the pancreas externally, you can see that there are a lot of lobes, as you can observe here, that it's quite lobulated, and all of these lobes are separated from each other with the help of septas. And inside this lobe, we can say that there are a lot of acini, and hence we can say that the pancreas is an acinar gland. So the typical acini looks like this. And if you look around this acini, you can notice that it's surrounded by loose connective tissues. So the first type of cell that we are going to be seeing in a typical acini is known as the pyramidal cells. As you can notice in this image right here, the pyramidal cells are circular and they are in close clusters. So the cells are circular, and then they also secrete digestive enzymes, bicarbonate, and water. Then we have the other type of cell known as the centroacinar cells. Now the centroacinar cells line the ducts that go and form the neck of the acinar gland. And you can actually observe that the first type of cell that is found more basally is cuboidal, but then that cube goes on growing and growing in length until it eventually becomes columnar type. So you can notice that in the more distal region, the entire structure changes into columnar type. And a typical acinar gland branches out like this, and we can observe a lot of different columnar centroacinar cells along the length of the ducts. That being said, we can actually notice that the centroacinar cells, they progress and they become elongated, and then it becomes it sort of becomes like it is responsible for being in close contact, and they communicate with the blood vessels and the connective tissues and the nerves in the more distal part. So they act like a connection. The next type of cell that we can see is known as the acinar cells. And if you look at the histology of the acinar of a typical acinar cell, you can notice that it has a basal nuclei. And this basal nuclei is supplied with a network of rough endoplasmic reticulum. This rough endoplasmic reticulum is proteinaceous. As we all know, rough endoplasmic reticulum is associated with the production of protein. And then these proteins are packed and are provided by Golgi networks. Then, lastly, at the apical region, we can notice zymogen granules. And these zymogen granules secrete eosinophilic substance outside through the apex of the cell. And then the last exocrine component that we're going to be looking at is known as the stellate cells. So these are the stellate cells, and the stellate cells are so that if you look at a typical stellate cell, you can see that it contains of long cytoplasmic projections, and they're only activated when there are pathologies. Now, another thing that I would like to add in a description of the stellate cells is that they are found in the periacinar space. As you can see, that this is the periacinar space, and this is the loose connective tissue. That is loose connective tissue, and this is the periacinar space. So between the loose connective tissue and the acini, you can notice the presence of stellate cells. So that was the entire exocrine component of the pancreas. Now let us move on and look at the other component known as the endocrine component. Okay, so let us look at the endocrine component. Though the endocrine component only makes up about 2% of the pancreas, it is very important, and it's usually made up of islets of Langerhans. Now, islets of Langerhans, although are more dispersed all around the pancreas, and there are usually millions of islets of Langerhans, but they're more concentrated near the tail region of the pancreas. Now, if you look at a section of the pancreas closely, you can notice that we can find a lot of different structures here. Firstly, there are polyhedral cells. Now, the polyhedral cells are richly provided by nerves and also blood vessels. Then one can, after staining, so we want to look much more deeper into this entire section that we took. And after using proper staining techniques, we can notice that we can find some alpha cells, then we have beta cells, delta cells, and the F type of cells. Now, the beta cells are the most abundant type of cells that are found here. And the beta cells secrete insulin, and about the 50% of the total composition of the cell is made up of the beta type. Then we have the alpha cells, which are responsible to secrete glucagon. Glucagon is also useful for the regulation of the glucose inside our body. Then we have the delta cells, which primarily are involved in the secretion of somatostatin. Then lastly, we have the F cells. F cells are typical type of cells that are found only in the pancreas that are usually used to secrete the pancreatic polypeptide.